Hello, in this video, we will begin to introduce inheritance and polymorphism in chapter 15. Inheritance is an important and powerful feature in C++ for reusing software. Suppose you are to define classes to model circles, rectangles, and triangles. These classes have many common features. What is the best way to design to avoid redundancy? The answer is to use inheritance. We're going to look at the inheritance now. So let's look at this classes, circles, rectangles. They have common features. They are all geometric objects. So the common features now can be generalized to define it in the parent class. So this is the geometric object class. It defines the common features, the color, and whether the shape is filled or not. And this is the constructor, geometric object. And so there's two constructors, overloaded and get color, set color, is filled, set filled, toString returns a string representation of this object. Now we define the derived class. So now here, circle is derived from geometric object. Circle inherits all the public members from the geometric object class. So we said the relationship between geometric object and circle is inheritance. So look, circle is derived from geometric object in this notation in the UML diagram with this triangle point to geometric object. Circle also defines its own data field, radius, constructors, how you construct the circles. There's the three overloaded constructors, get radius, set radius, and now also get area, get perimeter, get diameter, and toString returns a string representation of this circle. Now, this is the geometric object class, rectangle class. Rectangle is a derived class from geometric object class. In C++ term, we call this geometric object as a base class, and rectangle is derived class. You can also say this is subclass rectangle, and geometric object is a superclass. Or say this is the child class, parent class. Now we know that class defines a data type. So the relationship between the derived class and the base class is actually this. Rectangle, it's a subtype, and geometric object, it's a supertype. So now let's define this using this syntax here, the header file for geometric object. So this is same as before. It's just define this class here. And now, and this is the implementation for the geometric object. So let's look at the circle. For the circle class, you now need to use this notation, circle colon, public geometric object. So this is to denote that circle is derived from the geometric object class. So these are the constructors in the circle class and the functions, and this is the data field. It's a private data field. So here's the implementation for the so-called class. And now let's look at this. In the so-called class, look at the constructor here. So you constructed the so-called here. This is the radius, and here's the color, and this is the field. Now, this is going to be a problem. If you do this, color field are private data fields in the geometric object class. You cannot reference this. So what you have to do is you're going to write it this way here. It's coming here, and look at this here. You have to use set color and set field. So you can invoke this set, and set is set color that is public defined in the geometric object class. Is that this is the toString function. It returns a string representation for the so-called object, is returns so-called object. Please note that for the geometric object, we have this implementation for this toString. It returns geometric object. So coming back here, and we need to do this is so-called colon colon. So here's rectangle class using this syntax, colon, public. You have to write public here. Geometric object. So please look at the implementation for the constructor here. We have this is set color with a new color, invoking the set color defined in the geometric object class. This is in the rectangle class, we redefine the toString function. It returns the string rectangle object. So now let's write a test program to use all these classes. So this, we're going to include all the header files, geometric object, derived so-called derived rectangle. Creating a geometric object, set the color, set field is true, and now display this. This is the object shape.toString. So that is going to be geometric object. So look at this, and also you're going to define displays so the color and field. So look at the toString function implemented in the geometric object. So this is the geometric object. Okay, so let's come back here and see this is the, so here the next one here is the color. So that's coming from here, the color. So there's a space here. So that's why you see there's a space here, color. And so what is the color of this shape? Shape.get color. So what is field? Field is, so you're going to get to true or false. Is shape.is field true or false? For the so-called class, we create the so-called object with radius 5, set color, set field. Now, so-called.toString. So this displays so-called object. Get color, get field, and you're going to also get the radius, get area, get perimeter. So this is circle dot get radius, circle dot get area, circle dot get perimeter. The rectangle, creating a rectangle object with width 2, height is 3, the color is set to orange, its field is true, and this is rectangle.toString. It displays rectangle object. Get color is field true or false. Get width. So this is rectangle dot get width, and this is get height is rectangle dot get height, and this is the get area, get perimeter. So let's look at a couple of interesting points. First, private data fields in a best class are not accessible outside the class. Therefore, you cannot use this private data fields directly in the derived class. They can, however, be accessed, mutated through the public accessor and the mutator functions if those functions are defined in the best class. Not all is-a relationships should be modeled using inheritance. For example, a square is a rectangle, but you should not define a square class to extend to rectangle class because there is nothing really to extend from a rectangle to a square. Rather, you should define a square class to extend the geometric object class. For class A to extend class B, A should contain more detailed information than B. Inheritance is used to model the is-a relationship. Do not blind extend a class just for the sake of reusing functions. For example, it makes no sense for a tree class to extend a opposing class, even though they share common properties such as height and weight. A derived class and its best class must have the is-a relationship. C++ allows you to derive a derived class from several classes. This capability is known as multiple inheritance. So for interested reader, you can see the supplement 4.a for this multiple inheritance. This is all for the introduction to inheritance. See you on the next video.